Welcome to the day 3 tutorial. So on the first day we ran Pool Harbour. Yesterday we ran 3 models of the Solent. Very simple conceptual models, one with no Isle of Wight and a depth of 15 meters. Then we added the Isle of Wight, and then we added a raised bramble bank. So we created each of those meshes in Blue Canoe, ran the models in Pixus, and then looked at the results in Blue Canoe again. Now in today's tutorial we're actually going to build a much more complex real model of the Southampton water. But before we do that, in stage 1 we're going to explore some of the mesh capabilities of Blue Canoe in more detail, because we'll need to do a much more sophisticated mesh for the Solent. Now to do a good mesh of the Solent, to do a good mesh of any region can take several days. Some of the meshes I've worked on for Australia I've spent more than a week building. So it's a bit of an art form, and you want to do it well. The better your mesh is, it can sort of affect run times. So for this tutorial you'll need to download day 3. I've already done it here, the zip file day 3, and I'll explain that in the second stage. But to start with, we're actually going to use the four files that we downloaded yesterday for day 2 in the mesh folder. So we're going to focus on those to start with. So let's open Blue Canoe, and what we're going to do is we're going to build a series of meshes and just look at some of the features that we didn't spend time looking at yesterday. So if you go to open, let's open, in terms of the mesh, let's open, to start with, let's open the outline, and let's open the simplified Isle of Wight as well. So there's the outline of the Solent, and let's do the simplified Isle of Wight as well. And let's drag those both to a 2D view. And as you know, we played around with those yesterday. Now here it's plotted as lines, but if we click on the simplified Isle of Wight, right click, go properties, or double click, let's plot it not just as lines, but lines and points under the display tab. So display tab, lines and points, and you'll see why this is important in a minute. But let's generate a new mesh generator, file, new, create a new mesh generator, file, new mesh generator. We'll set this up to have a default edge similar to yesterday, 1500. Let's call this mesh 1. Click OK. Now let's drag the simplified Isle of Wight, like we did yesterday, to the soft lines, the outline to the outline, and let's run that mesh. Okay, and what I'm going to do is double click on that, go to the metadata, and I'm going to call this EG1, just for mesh 1. Okay, and what we can do now is drag that to the 2D view, and we see we see the same mesh as what we generated yesterday. Now what you can see is if you zoom in here, the points on this Isle of Wight land boundary, let's just bring the Isle of Wight up to the top, the points don't follow the grid. The grid around the Isle of Wight is determined by our default edge length, which we set up as being 1500 meters. So those points there are dependent on that if you use soft lines. But now let's look at what happens if we drag that to hard lines. So take the simplified Isle of Wight and drag it to hard lines instead. Let's remove it from soft lines. And let's run the mesh generator again with all the same settings as before. Click OK. And what I'll do is I'll double click on this mesh, and just to avoid any confusion, let's call that EG2 example mesh 2. So here you can see with the soft lines that the mesh around the Isle of Wight was dependent on our default edge length. Whereas if we compare this now with the simplified Isle of Wight, and I'll drag the simplified Isle of Wight as well. So let's remove the mesh one. Just interested in the simplified Isle of Wight. So with mesh 1, the mesh was determined by the default edge length. With mesh 2, what you can see now is that the mesh is actually influenced by these points. So if you use hard lines, then the mesh everywhere else is dependent on the default edge length, 1,500 meters, but now it's dependent on the nodes. If you just go to Window, tile horizontally, you can sort of zoom in and compare, but you can see every single grid node. So hard lines is useful if you want to increase the resolution along a boundary or around an island, for example. Okay, that's mesh 2. Now what we're going to do now is look at resampling. So here it was just default, but what we're going to do is resample this, and ideally along a land boundary you want these to be in exactly the same point. You can see here that actually let's just drag the simplified Isle of Wight to the top. You can see here now there's a big distance gap between there, and it's skewing the grid cells smaller here. What we want ideally is a point spread equally around the coast. So what we're going to do is click on the simplified Isle of Wight, right click and go resample. And what we're going to do is set equal distance, because we want an equal distance all the way around the mesh, and we're going to set this as 1,000 meters. What I'll do is call it re1000 is resampled. It's always good to put the value in there so that you remember. Let's set it up as 1,000 meters and click OK. Now we can just drag that to a new 2D view just to have a look at it. I'll drag the outline first and just drag so that was the original one. Let's remove that. Let's drag the actual outline of Southampton Water, and let's drag the resampled ones to a 2D view. If we double click again and put points, you can see now we've got nice equal points all around the coast at 1,000 meters spacing. So if we go back to our mesh generator, let's remove simplified Isle of Wight, and this time drag the resampled 1,000 meters to the hard line. Let's generate a new mesh, run it again, click OK, call this one EG3 just so we keep on track of ourselves, and drag that to the new 2D view. And what you can see now is, like before, the mesh exactly follows the points, but now we've got much nicer spacing. 1,000 meters isn't that much different from 1,500. So what we're going to do now is resample the Isle of Wight back here to 500 meters, just so we can see a real difference. Set equal distance like we did before, 500 meters, and again put 500 meters into the new name, just so you can keep on top of it. Let's remove the 1,000, drag the 500 meters back into the hard line, run a new mesh, call it EG4. So here you can see with the last one there wasn't that. It's slightly more refined, but it's not that much different. Create a new 2D view, and let's drag in EG4. And what you can see now is we have much higher resolution. So we're exactly following the 500 meter sample lines. Let's just plot those as points. So you see we're exactly following them, but much nicer resolution now. And if we look at all four, you can see this was the last one we created, 500 meters. That was the 1000 meters. This was just the original setting, and that's the soft line. So that's how you use hard and soft lines. The hard lines, the actual mesh is determined by the points. The soft line it isn't, and you can use resampled hard lines like we've used here to increase the resolution along either an island, or we could do it along the boundary as well. So that was soft lines, that was hard lines. But what you can see here is we've got another setting called hard points. So let's have a play with that. Now hard points is essentially where you can add a point anywhere in the mesh, and it will change the resolution of the grid around that particular point. So let's do that. So let's create a point. Now this icon here is where we create a point. If we go to Google Earth, in the Solent, if you type no man's land fort, there's a fort in the Solent located there. Let's zoom out. And it's located between Portsmouth and the Isle of Wight. If you get a chance, go and see it, it's very interesting. But this is a fort built during the World Wars, and what you can see is this will clearly influence the flows around that point. So what we're going to do is we're going to imagine we have a fort, well, we do have a fort there, but we're going to add it to the model. You see the grid cells here are quite coarse, it's not going to reproduce those conditions there. So what we can do is go to the new points icon up here, create a new point, click it, click a location approximately where the fort is, and you need to click on that again to close it. And we're just going to call this, again, you might want to come up with a better name, but I'm just going to call it point 1 to start with. Click OK. If we go to point 1, we need to now give that point a value. You can see it's got a value of 0, but we want it to have a value of our edge length. So if you click on Edit, let's make it quite fine. So let's say 250 meters. We don't want to go too fine for the time being. Click OK. And what we want to do now is, and just to make that point a bit more visible, I'm going to change the point size to 10, just so we can see where it is. Now what we're going to do is we're actually going to drag that point now into hard points. So in the hard lines we've got the 500 meters, but now in the points we've got this point that we created. I've just created one point. You can create multiple points for other things as well. Let's create a new mesh. Again, leave the 1,500 meters as default and click Run. Yes. Okay. Name this EG5 and let's drag that to a new view. And what you can see now is that the mesh has refined around that point. But the good thing is, if you click on your point and bring it to mesh 5, you can see that there is a node exactly on that grid point now. So you could set the depth of that to be 0, for example, and that would simulate the fort. Obviously that fort is too small to sort of represent in other ways. So now you can see we've got a mesh that in most areas has a default edge length of 1,500. Around the Isle of Wight it's 500, and around this point it's 250. Now the way in which the mesh around the Isle of Wight at this point sort of evolves outwards is dependent on your edge growth rate. So here we set it as 1.1, 1.2, but let's reduce that to 1.1 and create another mesh. What we'll do is call this one EG6. So here you can see that it quite quickly evolves to a sort of coarser grid. But if we use a higher growth rate, as we've just done, you can see now when we zoom out that the mesh is spread further out. So the finer grid cells actually spread out. If you just compare 5 and 6, you can see the growth rate. And again, you can use even lower growth rates to spread that out further. Ideally, you want a nice transition from. You don't want the transition to be too sharp. You want the cells to gradually grow bigger and bigger. If we go back to the mesh, we had default length of 1500. Let's reduce that to 2000. Click on Run. EG7. Create our 7th 2D view. Something hasn't gone quite right there. Let's just delete that. Cancel. Run that again. Good. Just make sure we're running everything correctly. Click on Run. Yes. Okay. EG7. Oops, I dragged the point, dragged the mesh. And now when you compare it, you should see now that further away, our grid cells are actually 2000 meters. So in deep water, for example, your grid can be quite coarse. So those are all the settings. So the growth ratio obviously affects the transition from fine to coarse. This is the sort of rest of the domain. So you can see we've used lots of nice things there. Okay, now there's something we haven't used yet. We used it in day 2, but it's this density function. And this density is another way of sort of refining certain areas of the grid that you want to be higher resolution than other areas. You can use a closed polygon, as we did in day 2. Remember, we had a polygon around Bramble Bank. You can use points as well, actually, to affect the density, or you can use another mesh. So we can create a mesh where the values of the mesh aren't depth but are size, which we will do later. So let's just start with the first two, the closed polygon. Imagine, for example, that we wanted a channel, the mesh to be finer up the main channel that comes into Southampton Water. What we could do is create a new closed line and just create the zone roughly where that channel is. Again, I'm just going to use all of these as default. Now let's say we want the value to be 500 meters resolution in that channel. Okay, so that's a new clothesline there. But what we can do is drag this new clothesline onto the density. Create our mesh generator as before. Let's leave it as 2000. Actually, no, let's go back to the 1500. Run that. Yep, and this should now be our eighth grid. So here you can see within the Solent itself, the resolution is coarse. Let's call this EG8. Let's set up an 8th 2D view. And you can see now our mesh has resolved up in that sort of channel zone. In that zone there. I probably should have made my channel a little bit thinner. So that's the first way in which you can use density, which was using a closed line. But the second way in which you could use density is to use points. So let me just drag the simplified Isle of Wight into my Zone 4, simplified model, smoothed Isle of Wight, which I'm going to use. Now what I want ideally is to make the mesh, along with everything else, make the mesh quite coarse out here where it's deep, and gradually as we get shallower and shallower to refine the mesh. But what we can actually do now is use points. So what I'm going to do is click 3 points along the bottom, 3 points in the middle, and 2 points at the top. Close that, and I'm going to call these points 2. Okay. Now what I'm going to do is edit each of these points in turn. So click on them, right click on them, go edit. Now these I'm going to give a value of 3,000 meters. I want my grid here to be quite coarse. $3,000. If I wanted an exact point, then I can edit it there. So these are going to be 3,000 meters. I'm going to resolve the grid now. Here I want it to be 1,500. And these ones I want to be 500. Okay, so these were 3,000, 1,500, and 500. Now what I can do is, let's open the mesh generator again, take those points 2 and drag these to the density as well. So we've got a new closed line which was up there, and we've got these points 2. So let's run that mesh again. Leave all the same settings as before. Call this mesh EG9. Apply. And drag that to the 2D view line. So what you can see is out here you've got the 3,000 meters. As we go up, it moves to 1,500 near those points, and then as we move up to the very top, it's 500. So that's another way of resolving. So we've used a resampled hard line, we've used a hard point, we've used points to affect the density, and we've used that channel as well. So we've used sort of all of the main features. Now we're just going to generate one more thing, but you can not only use a closed hard line, but you can use an open hard line. Imagine we wanted the grid cell to exactly follow the channel. If we zoom in here, you can see it doesn't do that. So what we could do is click rather than closed, create a new open line. And I'm just going to create that along there. Let's click on the end. Let's call that open line 1. We're going to give this a value of 400 meters. I want the resolution to be 400 meters along that line. Now we're going to resample that line because we want points to be all along that line. So let's just click on that, go properties, plot that as lines and points. So you can see at the moment there's only 2 points, one either side, but we want a series of points that the grid can follow. So if we go new open line, resample, equal distance here, let's resample as 400 meters. Remember to put 400 meters in the name, just so you can remember what that was. And if you go to the 2D view, let's select that as points. Now, ideally, now that's going to create a grid that follows each of those points. So what we can do is go back here and drag this resample 400 line to the hard lines. Run the mesh again. This will be our final mesh for stage 1. Click OK. Call that EG10. Okay, let's create a 10th 2D view. and drag that new mesh onto that. And what you can see now is that the grid is lined up exactly with those hearts points now. So again, this is quite useful if you have a breakwater or some other feature that's quite small that you sort of want to reproduce and you want the grid to follow that line. So you can see that in a number of steps we've gone through what each of the different properties are. You can create a grid that looks exactly like you want it to. I mean, this is quite a simple case, and you'll see it gets more complex when we have a real coastline. And it's quite a bit of work to sort of get all of the features you want. So just finally, what we'll do is zoom in, and it might be that we have a couple of grid cells that we don't like. There's a number of other features. I won't spend too much time on it now, but you can play with it in your own time. But if you go to View, Mesh Toolbar, this brings up a toolbar along the top, and if you click on your grid, there's a number of things that you can do. The first thing is just to analyze the mesh, and this is useful when you're comparing different meshes, so it gives you lots of properties about that mesh, and it tells you how many grid cells lie within certain areas. So again, it's a good way of checking, particularly let's say the smallest cell, and seeing if that influences your runtime. Sometimes your runtimes might be affected by your smallest cell and you want to just edit that one particular cell. So that's a good way of just sort of getting an overview of different meshes. And what you can do is, if you select the line between two nodes, the element, you can do a number of things. You can swap the edge. You just click on swap the edge, you'll see the line changes. You can split the edge, we've added an extra line, or you can delete the edge and you can see that's made a bigger cell. You can also click on a triangle. If you click in the middle, you might need to just zoom in. If you click on a triangle, you can delete an element. See, we've deleted that whole triangle. You can split the element in two, or you can split the element in three. So can you see there, we've removed away, we've added more grid cells there. So those are some just additional tools that you can actually manage. You don't want to manipulate too much of the grid, but if you've got a small river, for example, you might need to manipulate the grid in that way. So that's just an overview of some of the features, additional features that are available for editing meshes.